that, negative 5 times 5 is negative 25. Negative 5 times negative I is positive 5i. 2i times 5 is 10i. 2i times negative I is negative 2i squared. So we have negative 25 plus 15i. Negative 2i squared turns into 2. So negative 25 plus 2 gives you negative 23 plus 15i. Number 2. You'd be amazed. If I put one of these on the quiz, so I probably will, a lot of people miss problem number 2. What do you have to do there? Make this plus and distribute. And then, what am I supposed to do? Combine my terms. Negative 6 plus negative 8 is negative 14. 4i plus 2i is 6i. And that's it. Seems like every time I put one of these on the quiz, about a third of the class tries to FOIL instead of adding or subtracting. What did you think it said?
C. Looks like a C.
All right, number 3. What would we do here?
Take out the I's.
So when you have a negative radical 54, we can take out an I. What else can you break 54 into? So square root of 9 is 3, so that's 3i radical 6 over 6. Okay, remember, our directions are to write this in a plus bi form. So we have to split this up. So it's negative 9 over 6, 3 radical 6i over 6. So 9 over 6 reduces to 3 over 2. If you kept this as I radical 6 over 2, that's fine. I said radical 6 over 2. If you pulled the I out to the side, that's technically more standard, but I would take either one. So you did have to reduce the 3 and the 6, and you do have to break them into 2 separate terms. Do you understand it now? Our goal is just to write it in a plus bi form. So reducing our radical and then separating it so we have the real plus the imaginary. Number 4, we can't leave an I in the denominator. I want a plus bi. So what do I need to do? Plus 2i. So then if we put, we get 35 plus 14i plus 15i plus 6i squared. Put it on the bottom so you get 25 plus 10i minus 10i minus 4i squared. Combining like terms. So 14i plus 15i is 29i. 6i squared is, on the bottom, the 10i's cancel, so you have 25 minus 4i squared, which is plus 4. All right, so that gives me 29 plus 29i over 29. Wow, I made up a really nice problem. So then that reduces to 1 plus I. I can pretend I did that on purpose. Any questions there? All right. So we are having a quiz next Tuesday over sections 1, 2, and 3. I'm going to start each day between now and then with some review problems. So this kind of thing is from section 1. That will be on your quiz Tuesday. Okay? Then let's get out our notes from yesterday. We were working on solving quadratic equations. So if I gave you x squared plus 13x equals 3. How would we solve this?
Subtract 3 zeros.
Get it equal to 0. Then what do we do? You can't take x out of everything though.
It's a big slip.
Slip and slide. So we get x squared plus 13x minus 30. What multiplies to negative 3? If we did, well, 10 and 3 wouldn't work. So we have to do 15 and 2 because they have to have opposite signs. What do we need to do now? What's divide by 10 first. Now, technically, like when you write it back in factored form, at the 2x plus 3, you could skip this step and just set them from 0 or equal to 0 right there. Either way, it's fine, you'll get the same answer. So we get x to equal what? So if I said and if you set 5x minus 1 equal to 0, you get positive 1/5. So negative 3 halves and 1/5 are my answers. What if I gave you this one? Now, when we did slip and slide, I told you don't ever do slip and slide if your first term's negative because you'll mess up your signs later on. So if I don't want a negative 7x squared, what do I need to do? Yep, either multiply or divide both sides by negative 1. So then we can slip and slide. Multiply to negative 28 and add to positive 27. Negative 1. Divide our 7 back. 3x plus 4 and 7x minus 1. So if you set those equal to 0, we get just a couple problems to remind us where we left off. Are there questions over either of those? Let's take a look at this problem. Change my lettering. Let's just start over there. So if I said x squared equals 5, do I have to do a square root or slip and slide to solve this problem? No. I'm solving for x and it's only written in one spot. How would you get the x by itself? Square root. But anytime you add a square root to your problem, what do you have to put on it? Plus and minus. We have to get two solutions to these. So x can be plus and minus the square root of 5. I do expect your exact value, so I want it in radical form, but it does need to be in Lowest terms. Can we break down the square root of 5? No. That's called the square root method. If x is already by itself, you can just solve it by a square root. What if I looked at this problem? What would I need to do here? Okay, we have two options. Before I can distribute my 3, what would I have to do? Okay. So if you FOIL those, you get x squared minus 4x plus 4. Then what would you do? Now what? Okay. These all have a greatest common factor of 3, so you can either factor out the 3, or since it doesn't have a variable in it, you could divide both sides by 3. Now what? So two numbers multiply to -12 and add to -4. -6, +2. So if we set those equal to 0, we get 6 and -2. Is there another way we could have done that problem?
So why don't we have to put those ones at intervals?
Because it's not an inequality. So you could do the solution set, which is the proper form. I'm just letting you leave it as x equals. We only have intervals if it's a less than or greater than. If it's every number between them, since it's only these two numbers, we don't need it. So nobody can think of a different way to solve that original problem?
I like that way.
You like this way?
Yeah, that's what it's good.
Okay, that works. How many places was x written in the original? Could you get x by itself? How do you get rid of the 3? Could I have divided both sides by 3 to start? Okay, how do you get rid of the square? Square rooting. With that, you have plus and minus. So we get x minus 2 equals plus or minus the square root of 16 is 4. Then what would you do? Yeah. So think of it, this is like saying two separate problems. X minus 2 can equal 4, or x minus 2 can equal -4. So if you add your 2 over, you get x to be 6 and -2. So two different ways, both give you the same answer. If I put these problems on test or quiz, I'm not going to tell you how to solve them, I'm just going to say solve it. So as long as you can get to the answer, that's fine. Any questions on that one? Let's try some more. Yeah. So, my two options, I could multiply this all out, or I could just square root. If you add square root, you do plus and minus, so you get x minus 1 equals plus and minus, the square root of 4 is 2. So that means x minus 1 can equal 2, or x minus 1 can equal negative 2. So if I add over my 1, x could be 3 or negative 1. You can write them in solution set if you like, that's the squiggly brackets, not parentheses. Or you can just leave it as x equals, I don't care. What about D? Square root. With that, we have plus and minus. What is the square root of 49? Negative 49. Okay. So the square root method does allow us to find those imaginary solutions. Okay. Let's do 2 more. On E, can I just square root and get my x by itself? No, because I have x times things. So I have to first multiply it out. So I get 5x squared minus 14x equals 3. Then what? We have to get it equal to 0, so subtract over the 3. And then we can slip and slide. So multiply negative 15, add to negative 14. Negative 15 and positive 1. Divide our 5 back. 3x minus 3. 5x plus 1 equals 0. If we set each of those to 0, what does that give me? 3 and negative 1. Last problem like this for today. What would we do? I only have an x in one spot, so we can solve for it with the square root. When we do that, we need plus and minus. So on the left, it just cancels my square, and I get 2x plus 3. On the right, I have plus and minus. How would I break apart the square root of negative 8? And what else would I have to take out? An I. So the square root of 4 is 2, so we get 2I radical 2. All right, I'm trying to get x by itself. Next, I have to subtract over my 3. These aren't like terms, so you can't actually combine them. We're going to keep our answer in standard form, a plus bi. So I'm going to put the real number, the negative 3, plus and minus my imaginary term, 2I radical 2. What's my final step? Okay, we have to go with standard form anytime we have I, so we do have to break this up. So it would be negative 3 over 2, plus and minus 2I radical 2 over 2, the 2's drop. So just I radical 2 over 2. So make sure, if you have something involving an I, your final answer has to be A plus BI. Any questions there? I do have one final example, it's just a little bit different. So I want to do this one before you start your homework.
You said that was.
I know, I forgot, I lied, I'm so sorry. This really is the last one.
Yes, you got me beat.
You haven't even read the problem yet.
I looked at it.
You looked up and saw words.
Word problems. Weakness.
So a quadratic equation, ax squared plus bx plus c equals 0, has solutions of negative 5 and 3. I want to find what a, b, and c were to start with. I'm asking you to work backwards. I'm telling you, you solved this and got x to equal negative 5 and 3. So, work backwards. If x was equal to negative 5, what was in my parentheses?
I can break it. Word backwards.
So if you think about this, when we set them equal to 0, if you brought the 5 back over, it was x plus 5 equals 0. So that means there was an x plus 5 in my parentheses. If you brought this 3 over, x minus 3 equals 0. So my parentheses had an x minus 3. So this is what it had to be before I got my solutions. X plus 5 times x minus 3. I want to know what a, b, and c are, so what do I need to do with this? Boy, I'm just asking you to recreate the original problem. So it was x squared minus 3x and plus 5x plus 2x. So multiply negative 15 and add to positive 2 would be plus 5 and minus 3. Oh, why did I just factor it? I don't know why I did that. Habit. I was just trying to find A, B, and C, right? So what's my A? 1. What's my B?
2.
What's my C? Okay. So there is a question like that on the Math Excel. She's asking you to work backwards to figure out what the original was. All right. Now you can start your homework.